Unit vectors are vectors that are 1 unit long. These little vectors that all have a magnitude of 1 are all unit vectors. There are 3 extra special unit vectors that point in the directions of the positive x-axis, the positive y-axis, and the positive z-axis. And these 3 vectors are named I, j, and k. I goes 1 unit in the positive x direction, and it doesn't go anywhere in the y or the z direction. J goes 1 unit in the positive y direction, and it doesn't go anywhere in the x or the z direction. And K goes 1 unit in the positive z direction and doesn't go anywhere in the x or the y direction. We're going to be doing a couple things with unit vectors. The first thing that we're going to do is we're going to be writing other vectors in terms of these unit vectors I, j, and k. This should be an I. Alright, so for example, we have 2 vectors, vector AB and vector CB, and they're written in IJK form, and we want to find vector AC and the magnitude of vector AC. So first we remember that vector AC is equal to vector AB plus vector BC, where we go from A to B and then from B to C. B is the stopping point in the middle on our way from A to C. Also remember that BC is equal to -1 times CB. So we have this vector equation that gives us vector AC. Alright, so vector AB we have written up here in IJK form. So we could rewrite it in component form, and the x component is -2, the y component is 5, and the z component is 1. And we want to subtract from that vector CB, so -1, -2, and 3. This gives us vector AC in component form: 2 minus -1, 5 minus -2, and 1 minus 3. Okay, we could also write this in IJK form as -I plus 7j minus 2k. To find the magnitude of vector AC, we want to use the distance formula. So we're going to square each of the components in the vector and add those squares up. So we have -1 squared plus 7 squared plus -2 squared. Square root of that, so that's root 1 plus 49 plus 4, which is root 54, which simplifies to 3 root 6. The next thing we're going to do is we're going to find a unit vector in the direction of a given vector. So say this was our vector AC that we found in our previous example, and we want to find U, a unit vector that has the same direction as AC. So AC has a magnitude of 3 times the square root of 6, and we want the vector that's parallel to AC but has a magnitude of 1. So what we need to do is we need to take this vector AC and we need to scale it to have a magnitude of 1. So our unit vector in the same direction, we want to take the length, or we want to take the vector AC, and we want to scale it so it's 1. So we're multiplying by the reciprocal of the length, or dividing each one of these by the magnitude of the entire vector. And this is a unit vector that's in the direction of AC, and it has a magnitude of 1. We could also write it in IJK form, if we wanted to, as -1 over 3 root 6I plus 7 over 3 root 6j minus 2 over 3 root 6k. Alright, In general, a unit vector, which is usually a u with a little hat, in the direction of some other vector, say vector b, is given by this vector equation. The unit vector is equal to 1 over the magnitude of b times vector b. The final thing we're going to do is a variation on what we just did. We're going to find the unit vector that points from point A, whose coordinates are given, to point B, whose coordinates are given. Alright, so the vector that points from point A to point B is vector AB. And vector AB, we want to take the B components and subtract the A components. So 1 minus 4, negative 2 minus 0, and 1 minus negative 1. So vector AB, the vector that points from A to B and goes from A to B, is going to be negative 3, negative 2, and 2. Now in order to find the unit vector that's in the same direction as this vector AB, whichever way it's going, I want to find this unit vector. First I need to find the magnitude of vector AB. Alright, so the magnitude is going to be the square root of the sum of the squares of the components. Which is going to be root 9 plus 4 plus 4, or root 17. Now that I have the magnitude, I can write an expression for the unit vector by taking 1 over the magnitude and multiplying it by vector AB. So this is it in component form, or you could write it in IJK form by taking negative 3 times 1 over root 17, and that's multiplied by I hat, minus 2 over root 17 j hat, plus 2 over root 17